about areas of sectors, segments, and annuli today. Okay? And first you have to know what each of those things are. So a sector is basically a piece of a circle. So if I were to draw a circle, which I'm about to do, there's a circle, and I get my tool here, and I make this thing here, and this here.
Is this a conjecture?
It will be in a minute. Okay. And this, and then I'm going to even shade. I'm going to use this school tool. This thing here. It is a conjecture. We'll get to this. Okay. I'm not a very good colorer.
Oh, you went outside the line.
You guys see how it is. Okay. I got seasoned coloring. All right. So anyway, this thing here is called a sector of a circle. Okay? And it's a lot like we already did arc length, right? And if you call this n, that angle has a measure of n degrees. Okay? And the area of a sector is just n over 360 degrees times what? Pi r squared. That's how you find the area of the sector. Anna, you should write this on your conjecture sheet. I believe this is on your...
We already did this.
What do you mean n degrees?
N degrees. So...
Like the angle?
Yeah, the angle. Okay? So it's the number of degrees out of 360 times pi r squared. Is that on your conjecture sheet? Okay?
Yeah.
Okay. It is. And so, for example, we have some straightforward ones.
What's the number of degrees of what?
The number of degrees of
Of the angle.
Okay? So,
Of that shaded section.
of this shaded section. So, we'll do an example. Here's an example. Here's a circle. Okay? And I get my line. We settle down, all you guys. And let's say that that's all you have, except that you do know that this is 6. And they say find the area of the sector. So area equals, what's n in this case? 90, 360th times pi times 6 squared. Okay? What's 93? And a lot of times these fractions reduce nicely. How can I reduce 90 to 60th? 1/4. And what's 6 squared? Times 36. And so you get, how many? 4 goes into 36, how many times? 9 pi. And if that's in inches, you could just leave it exactly as 9 pi inches squared. If they ask you for a rounded off answer to the nearest 10, then you multiply. Is that hard?
No.
Wait, will you keep that up?
Yeah. Quality notes. That's quality. Good. Good enough? Turn?
No, wait.
I'll come back.
Oh, wait, no.
No?
Oh, wait. Oh, wait, okay, I got it.
Got it. Okay. Next thing is the area of a segment. Area of a segment. Now you might think of a segment as a line, but a segment of a circle is a different thing. Alright? So to do that, first I'm going to draw a circle, then I'm going to draw, I could have gone back and copied that last one. Let's make it kind of word angle. And then I'm going to draw from here to here. And this shaded area right here, oh, that's not my shading tool, this thing. Let's see if I could stay in the lines this thing.
Don't make it too small.
Should enough. Come on, give me a break. This thing here is called, that shaded region is called a segment of a circle. Okay? So anyone want to guess how I would find the area of a segment of a circle? What would I need to subtract? I have to subtract two things. What do I have to do to Maggie?
Well, don't you have to find here's the area of the circle, then you have to find the area of that, like, sector,
Right.
and
So,
then the area of the...
right. So it's the area of the sector, right? So what you would have to do is take the area of the sector, which looks like this, and I do have a Thomas in this stuff. Where is he? There he is. Thank you. And then you have to subtract the area of what?
Area of the triangle.
The triangle, right? Because if I take this triangle, in this case, this one over here, right, and I subtract that triangle, okay? Sector, that's what we learned, that was the last thing we learned, right? So, and I subtract the triangle, and I'm going to end up with what's left over, which is the segment, right? So, if you want well, we already have a formula for the area of a sector, so you can,
Where's the triangle?
what? Where's the triangle? This triangle right here.
Oh.
So if I take this piece and subtract this piece, what's left is going to be
they'll give us like the
segment.
numbers, right?
Yeah, so let me give you an example, okay? So for example, I could do it on the same page. Maybe I can. Let's do it on a new page. New page. Now I have to draw a new picture. That's okay, right? So here's the third, and I'm going to make it, just because they do this a lot in this book, because you guys don't really know that. And let's say that this is 8 inches right there, that radius. And believe it or not, that's enough information to find the area of this sector or segment right there. Can anyone tell me how I would find the area of that piece? Right there? How would I find the area of that piece? Go ahead, Matt.
So you would take 90 out of 360.
90 3/60 times
Times R squared.
times with, in this case, R is 8. So 90 3/60 times pi 8 squared minus what?
8 times 8.
Perfect. Do you see where you got 8 times 8 divided by 2? Because these are radii, right? And since it's a right triangle, in this case, you just go 8 times 8 divided by 2. Now, if you had another triangle where this was not a right angle, then you'd have to know the height going across it, right? But in this case, it's a right triangle, so all you do in a right triangle, you can just, this is the base and the height, right? Which are both 8. So then simplifying, I get 1/4 of pi times 64 minus, what's 64 divided by 2? 32. And simplifying a little bit more, 4 goes into 64 16 times. 16 pi minus 32. And that is okay to leave it like this, inches squared. Okay? Now, if they ask you for rounded off to the nearest tenth, then you plug it into your calculator and round it up. Easy so far? Okay. Then we have the next thing. And then I have one more example and two more examples. And then we'll be ready to roll. Okay? This thing here, okay, this is called an annulus. Okay? And an annulus is like a donut. Okay? So you have one circle here, and then you have a circle in between the circles. Okay? So if I'm talking about an annulus, I'm talking about the area between the two circles.
Wait, what was the formula for the last one?
Just the
Sector
area of
minus
this,
triangle.
just think of it as sector minus triangle. Okay, so here's the annulus, I know. Must be a better way to do this. But the donuts, or whatever it is. Sorry.
Oh.
Good, beautiful coloring. That was really good.
Oh.
So that's an annulus. And in a circle, okay, this is big R, and this one here is little r. Okay, so they call this big R is the radius of the big circle, and little r is the radius of the little circle. Who thinks they could tell me the formula?
Big R minus little r.
Not just big R minus little r.
Area of
Maggie?
big R.
Area of big circle
Right,
minus
it's
area of
big
little.
circle minus little circle. All right, find the area of the big circle. Pi big R squared. So it'd be pi big R squared
So that's big circle.
minus pi little r squared. Do you understand that? Because if I take the big circle and subtract the inside circle, then I would get the area of what's left. Good? Right. So these problems can get a little bit tricky because sometimes what they'll give you is they'll tell you that the bit from here to here, okay, from here a little bit tricky, not very tricky. Say this is 6 there, and this piece from here to here, just from here to here is 2. And they'll say find the area of the annulus.
Wait, do they not give you
Right.
values for?
Yeah, you have to do a little thinking to say, well, if this is 2 and the whole thing is 6, then little r has to be 6 minus 2 or 4, right? So the area is going to be pi times 6 squared minus pi times 4 squared. And you should simplify this, which is 36 pi minus 16 pi, which is how many pi's altogether? You can subtract pi's like that. So what's that? 36 minus 16 makes 25, okay? Which if I did that out, so you could either leave that exact, if they ask you exact, or you can multiply it out. So that would be about 62.8, and if these are inches, okay, then it would be 62.8 inches squared. Questions on that? And then you have some problems on your homework where they're going to ask you to go backwards, okay, which can be much more trickier for people. So I want to give you a trickier one, like this, because you guys are advanced students, and you should know how to do advanced student problems. So say I have a circle, and a circle and a circle, and then I have
Another circle.
oh, I'm going to drop, let me see how my picture is. I have this going there, and that going to there. Oops, that's from the center, even though I can here is angle X, right? And all I tell you is that that this whole piece from here to here is 12, and this piece here is 2, and this area in here, okay, is the area of that piece is area equals 10 pi. And they say find X. So this is a little bit trickier because this is a piece of an annulus, right? Right? So to find this piece, I would do, how much is this, the inner radius? If this is 10 and that's 12, what's the inner radius? This is 10, right? From here to here. And so what you know is that X, which I'm going to call, what?
A equals 10 pi, is that for the whole circle?
Yeah, no, for this sector. The area of this, they give you that the area of this little piece is 10 pi. And they say, find X. Okay? So what you have to do is you have to go X over 360 times pi big R squared. What's big R squared? 12 squared minus pi times little r squared, which is 10, equals 10 pi. You guys follow what I did? Because they give you this area is 10 pi. And you know that you have x 3/60th of the annulus, right? So you're kind of combining a sector with an annulus with a segment, a sector and an annulus. So this is a piece of an annulus. It's x 3/60th of that annulus, okay? So you get x 3/60th of 144 pi minus 100 pi equals 10 pi. Then I'm going to combine like terms. X 3/60th of, how many pi's is that? 44 pi? 44 pi equals 10 pi. Do you know that I could cancel out both of those pi's? Hello? You know that? Only if I use a green marker. I can cancel those out. So I get x over 3/60th times 44 equals 10. Now what?
And then, divide by.
Multiply both sides by 360. 360 times that. 360 times that. Okay? Boom. 44x equals 3,600. Divide by 44. Anyone got a calculator that could do that for me? 3,600 divided by 44, what do you get? 13. How much? 30. For some reason I thought I made a problem that came out even. So x is about equal to 31.81. So agree. About. Not exactly, but about. Okay? And that's how you do something like that. I think the one, yeah, that's a hard problem. So they do get a little more complex like that.
I have a question. I don't know how you tell how to combine the equation. I'll show you by the way. It's 81.81.
It's 81.81?
Yeah.
Oh,
How do you get? I don't get that.
that's an 81. How do you
get how to combine like the equation?
well, because I know that just this by itself would be this, right? Pi r big R squared minus pi r little r squared. But I only have part of that. What part of that do I have? I have x 3/60th, because the whole thing would be 3/60th. 3/60 3/60th. You see?
So
I have x 3/60th today.
on the area of a sector,